Hey guys, welcome to the immune system. Now, before I start chapter 43 on the immune system, I want to just reiterate a couple things. We're learning the immune system as it relates to cell communication. So just keep in mind those three steps of reception, transduction, and response, and keep those in mind as we learn through this immune system. I'll also tell you this, I think you guys will enjoy learning about this and appreciate learning about this, especially with the environment that we live in today with COVID. I would guess the vast majority of individuals on this planet right now, they know very little about how our immune system works. And I think as biology students, it'll be enjoyable for you guys to be able to kind of impart some wisdom on how this stuff works and why it really matters, especially right now. So, I know in the past year I've never appreciated having learned this concept more than I have since this COVID environment has occurred. But here we go. So there's really two types of immunity that we work with, and that is innate immunity and acquired immunity. And when we look at those two, innate is exactly probably what you would expect. Innate is what you're born with. It's more barrier defenses. It's not as specific. Versus the acquired is something you have to acquire. Your body has to learn this um, and mount a defense, but you, without exposure, your acquired immunity does not exist. So an animal is going to be defending itself from all kinds of things, viruses, bacteria, and that could come from our food, the air that we breathe in. It could come from the water that we drink, any number of things. But your body is constantly defending itself. So again, as we look at the innate immunity, this is present before any exposure. So exposure is not needed for this. You naturally have this. It is non-specific, and what that means is it attacks anything uh, that the body recognizes is not supposed to be there. You'll hear me talk about this as self versus not self. Your body, it does a really nice job of recognizing what is yourself and what are cells that are supposed to be there that are of yourself versus not self, which is obviously something that should not be there. It's not normally a part of your body. So there's certain parts of the immune system, like external barriers, such as your skin, your mucous membranes. There's also internal parts to that. That would be cellular and chemical defenses, things like macrophages and phagocytic cells that ingest and destroy things. But again, they're not specific. It's not like they're looking for only the common cold or only for the COVID virus, right? They're looking for just self versus not self. Versus the acquired immunity, which is also sometimes known as your adaptive immunity. And this develops only after exposure. In other words, if you're not exposed, you do not have these defenses yet. You only have the innate part. So this is where you maybe have heard it's really good idea to get vaccinated on a lot of things as long as the vaccine is good and viable. It's good to get vaccinated because what you're building is this. You're building your acquired immunity. Without exposure, you don't have this. You have nothing that is specific to, let's say, a virus or a bacterium. You don't have specific responses. Your body doesn't have specific defenses to mount an attack against that thing until it learns it and has exposure to it. Usually, we would read an article, and one of the things that the article actually opens with is you should encourage your kids to eat their boogers, which is an interesting concept. But the reason why is so that they build up this acquired immunity. So when we look at some of the defense protocols, which obviously were needed for COVID to lower the hospital stays and not have they talked about lowering the peak back in the spring. But part of the thing that they're really worried about this winter is we've been quarantining and trying to stay away, or so many people have been trying to stay away from things. We're worried that our adaptive immunities are down right now because we haven't been exposed to as much. We've been staying to ourselves so much more. So that is a legitimate concern going into this winter. But again, I digress. Acquired immunity. Um, this is going to be part of your reading guide. I would encourage you to have that out right now. But external defenses would be a part of our innate immunity, skin, mucous membranes, some secretions on the surface of your skin uh, or within your body as well. Internal defenses like phagocytic cells, antimicrobial proteins, and your inflammatory response and natural killer cells, which do exactly what they sound like. They kill things. This is, again, non-specific responses. We'll go through a couple of those in a little bit. And then when we get to the acquired immunity, that is, again, you have to have exposure. So there's two really types. There's the humoral response, which its main job is to create antibodies. And then you have the cell-mediated response, which includes cytotoxic lymphocytes. Basically, their job is to directly destroy things. So you have antibodies and then directly destroy things. So we'll get into those. Now, just again to review, the innate immunity provides a broad defense. This is very not specific. You do have some external defenses like your skin and mucous membranes. When we encounter several, a pathogen would encounter these things. But again, it's basically just to impede an attack. It's not a specific response to a specific thing. It's just recognizing self versus not self. Good things for this would be your skin and mucous membranes. Again, these are going to prevent the entry. Really, any opening in your body has these mucous membranes to prevent things from getting in. If we're looking at your trachea, which is your windpipe, if you're thinking the pipe that goes down into your lungs, there's these ciliated cells, which are these little hairs, and what they do is they sweep things up. And when you're sick, you might notice you cough up like phlegm or pus, it kind of looks like, or whatever you want to call it. But what you're sweeping up is what your lungs are trying to get rid of. Okay, they're trying to get rid of these microbes, and that's what you're coughing up. So this is like your first line of defense. I kind of think of it as it's your skin and your mucous membranes. Again, the goal is to stop stuff from getting in. If we look at the secretions on our skin, it actually creates a pH of about 3 to 5, which helps to prevent colonization of microbes. And then we also have like the washing action of our saliva, our tears, our mucus secretions. Again, all of this is trying to stop colonization of any sort of virus or bacterium. We also have the harsh environment of our stomach. If we ingest something that not many things can survive. So then we have the internal. I think of this as like the second line of defense now. So this would be phagocytes, would be like white blood cells. Well, and something interesting is there's white blood cells that are specific. That'll be a part of the acquired immunity that we'll learn a little bit. There's also white blood cells that are a part of this, okay, the non-specific part, the innate immunity. And they're called a couple different things, but one of the things is a phagocyte. And phagocytosis basically means engulfing. So that's what you're seeing here. It's engulfing some sort of microbe, bringing it into a vacuole, and the lysosome, if you remember, it's a digestive organelle, is going to fuse with that and break it down and spit it out. But it's not specific. It doesn't know what this microbe is. It just knows it shouldn't be there. It's going to try to get rid of it. So macrophages is a specific type of that phagocyte. Macrophage is a big eater is what that stands for. They are constantly migrating through our body, both in the bloodstream and the lymphatic system as well. They would be found in your lymph nodes. It's one of the reasons you've probably, if you've ever been sick and gone to the doctor, they check around like your neck area to see if your lymph nodes are inflamed. That's what they're checking for. If they're inflamed, there's likely an infection in there that your body is fighting. There's numerous proteins that are also part. Again, this is all this stuff, right, is if you were an immune system doctor, it would be really important. Do you have to know all this stuff for your test? No, remember, we're learning this as it relates to cell communication, and we'll get into that specifics in a little bit. But all these cells are a part of your immune system. This is the inflammatory response. So this is a response to an injury. So if we look here, we have something that breaks the surface of our skin, and there would inevitably be pathogens that are beyond there. The first thing that happens is we see some swelling here. Okay, so that's inflammatory. Inflammatory means basically some swelling in that area. But what needs to get there is blood clotting elements as well as white blood cells to take care of whatever has entered our body that shouldn't be there. So there's chemicals that actually recruit these phagocytes to come take care of the issue, right? Okay. So that would be done again by these chemokines. It's a chemical that attracts or recruits these things to clean up the issue. Natural killer cells are another part. They trigger apoptosis, which remember is programmed cell death. So they're basically going to trick that cell into destroying itself. All right, now if we get into the acquired response, remember this is specific. It requires exposure. Is another part of your body's second line of defense, and it involves more white blood cells, lymphocytes. While microbes are under attack from phagocytes of the innate immune system, they would also encounter these. And what we're looking at here is any foreign molecule. We'll go into all kinds of different things that could be. It could even be a mistake by your body, and we'll go into that. That's with allergies. We'll get into that in a little bit. But an antigen is anything your body recognizes as a foreign molecule. In other words, that it thinks it shouldn't be there. So your body's going to try and learn this and then basically mount an attack against it. So the antigen recognition is the first part. So your body has to be able to recognize that it shouldn't be there. Okay, and there's two types of cells that really do this. There's B cells and there's T cells. There's going to be constantly circulating through your body looking for things that shouldn't be there. And they have antigen receptors. So if I look back here, an antigen has a specific shape. So these cells would have those shapes on them looking for, something that shouldn't be there. So this is just a B cell. You see these would be those receptors that are out there looking for, again, a specific shape, a specific antigen that it is trying to recognize and then destroy. T cells do the same. They still have that shape, that specific thing that is pushing it out there. T cells will bind to specific fragments of that, and there's these things that are called MHC molecules. Now remember the three steps of cell communication: reception, transduction, response. So the MHC, major histocompatibility complex, its job is the reception piece. So if I go here, here's our MHC molecule, and it's going to be the reception of it. Okay, it's going to recognize and present this antigen out. Okay, it's part of reception. It's going to present this to the in this case, the cytotoxic T cell, and the cytotoxic T cell is going to, now learn that new thing and mount an attack against it. Okay, so the MHC molecule's job, this cell has a piece of the antigen. It's going to present it to the outside. That's what the MHC molecule does, but it's going to help with the reception piece of cell communication in the immune system. Same thing here. You're seeing this MHC molecule present an antigen to a cell that's going to learn and mount an attack against it. But its job is to present it. It's part of the reception. Lymphocytes are going to arise from stem cells in your bone marrow. That's where they come from. They're built and made in the bone marrow. And When we look at these two types, we have B and T cells, right? And where those B and T come from is where they originate from. B cells come from your bone marrow, so B for bone. T cells come from your thymus gland, T for thymus. Let's skip ahead a little bit here. All right. B and T cells are maturing in the bone marrow and the thymus, depending on which cell we're talking about. And those lymphocytes bearing receptors are going to already be present in their body. So here's what happens here. In the clonal selection of B cells, in other words, the rapid production of them, what you're going to create is memory cells and plasma cells. Okay. Now, what are these plasma cells doing? Well, what do you see here is an antibody. All right. So these B cells are going to get activated. In other words, they're turning on. Our body has learned a pathogen and we need to mount an attack against it. There's two things that it does. So these guys have been activated. They're going to create memory cells. That's for future. So if we're ever exposed to this pathogen again, we have a means to take care of it faster. So that's one piece of it. The second piece of it is we need to create antibodies, and antibodies are ready for the here and now. And we'll go into what antibodies do in a minute, but that's the two things these B cells are going to do is they're going to create memory cells for future, and they're going to create antibodies for the here and now. Antibodies are ready to take action right away. So that's their job. Now, I mentioned that we have a future. We do part of this for the future. And so if we're looking at a primary immune response, in other words, the first time you've ever been exposed to something, in order for your body to mount a full attack against it, it takes 10 to 17 days. Okay? But in a secondary immune response, it takes only 2 to 7 days. Okay? Why is that so much faster? Well, if you remember, I talked about those memory cells right here. These memory cells are going to be in your body forever, okay, for a long time. You have these memory cells that are going to remember this pathogen and be able to take care of it. So if I go back to this graph now, here's our primary exposure. You can see our body mounts an attack, right? But it's not really all that amplified. But the second time we are exposed, look at this, boom, our body is ready. Reason why? You already have those memory cells ready. Your body doesn't have to learn it. It already has learned it, and we can mount an attack. This graph right here shows a classic example of why vaccines are important. Because basically, what we've tricked our body into doing with a vaccine is this primary response. However, with a vaccine, you have a weakened pathogen or a dead pathogen. So you've tricked your body into learning this while you can't get sick in this time. So that's why a vaccine, it basically does. It takes care of the primary exposure where your body would be at risk. Now, when you're actually exposed, so let's say I just got the flu shot a couple weeks ago. That's my primary exposure to that variety of flu for the year. Now, if I would get exposed to that flu, boom, my body can make a really amplified, you can see very quick response, much quicker, much greater magnitude, and it's also more prolonged as well. So it's a better attack. That's why vaccines are a good thing. So we look at these two parts of our acquired immunity. There's really the humoral and the cell-mediated, and that we'll get into now. So if we look at this does a nice job. It all starts with a helper T cell. Now, do you need to memorize what helper T cells and cytotoxic T cells and B cells do? No, you do not. Although it is, I think, interesting to learn. So we have a helper T cell, and this is like the initiator guy. It starts the process. He's going to recognize and be activated basically our body has recognized that something shouldn't be there, something is causing a problem. Our helper T cell is going to be, okay, now we got to learn this thing and we got to do something about it. So it's going to do two things. The helper T cell does two things. One, it's going to activate a B cell, and that B cell is going to do what I said before. It's going to create plasma cells, which create antibodies, and it's going to create memory cells. Memory cells are for future, antibodies are for the here and now. It's also going to activate cytotoxic T cells. What do cytotoxic T cells do? Well, you're going to make more memory cells for the future, and you're going to create cytotoxic T cells, which directly destroy. Okay, so what did they do? The helper T cells basically activated two things: antibodies and cells that can directly destroy, and you did memory cells for the future. So all of that leads us to this. So here's what we're seeing. We have a cell that has recognized a pathogen. It's going to activate that cytotoxic T cell. The MHC molecule has presented this thing out and says, hey, we got a problem here. We need to learn this thing. So the helper T cell says, okay, that's my job. We got recognize this shape. I've recruited two types of cells. We got B cells and cytotoxic T cells. The B cells are going to create antibodies. The cytotoxic T cells are going to create cells that will directly destroy. They're also going to create memory cells. Here's what you're seeing here. This is an example of a cytotoxic T cell. So this would be the cell-mediated response. We have a cytotoxic T cell recognizing this. We have a cell that has been taken hostage by a virus, for instance. Cytotoxic T cell is going to secrete some chemicals that are going to destroy that cell. Remember I said directly destroy. That's what the cytotoxic T cell does. It's also going to do the humoral side, which is with the B cells. So let me get to that picture. Here it's the helper T cells activating. Okay, it's going to, here we go, B cells. B cells are going to create some plasma cells, which create antibodies. Again, I'll get into more on antibodies and what they actually do in a little bit. Here's our memory cells. I go back to the previous one. We also have memory cells from the T cells. All right, antibodies. What do they do? Here's what I think of when I think of antibodies. They are marking for future destruction. They're marking and flagging for removal. They're, in essence, they're going to attach to the pathogen. Here we have a virus, bacterium. These little dots are more antigens, things that shouldn't be there. What you're seeing is these little guys here, those are the antibodies. And they are basically trying to make that thing not be able to do anything anymore. And it's marking it for destruction. So you can see they've flagged this thing down. Now these white blood cells can destroy it. Okay, that's what the antibodies really do. They mark for later destruction. All right. Sometimes our immune system plays tricks on us or causes us challenges, is maybe a better way to say that. And one of the things that it causes challenges for is for tissue transplantation and blood transfusion. So if you've ever given blood, you probably have heard, they tell you your specific blood type so that that when they give your blood to somebody else, it's not going to cause problems. Because if they gave the wrong blood type to somebody, our body would see that as a pathogen. It would recognize that as it shouldn't be there and destroy it just like it would a bacteria or a virus. So we need that close match. So if I have type A blood, I can only get type A blood. If I have type AB blood, I can only get type AB blood. Okay, and the reason why is because of those things that are on the outside that basically the body can recognize as either self or not self. Okay, not self. Their antibodies to that is already going to exist, and if it is not a close match, our body is going to destroy it. Not good, right? So if we look at this, this explains kind of who can get blood from who. So that does a nice job of that. O is the universal donor. AB is the universal acceptor. You can get blood from anybody. RH factor would also be a part of that. There's also, it's not just limited to blood, it could be tissue transplantation as well. So if you get like a skin graft, if that is not a close match, or if you get a kidney from somebody, if you don't have a close match, your body will destroy it. So oftentimes what they'll do, if you're going to get an organ transplant, is the recipient will take immunosuppressor drugs. Basically, what that means is they're going to suppress your immune system, or just weaken your immune system, so that your body will be able to accept this. If they don't do that, you're very susceptible. Your body could attack your new thing, the new organ that you got, and basically defeat the point. Other things that can kind of trick our immune system would be allergies. Allergies are exaggerated, hypersensitive response to antigens that your body shouldn't have, but it thinks it's going to cause problems, and even though it won't. So that's what allergies do. So if you're allergic to, maybe you have hay fever like I do, maybe you have an allergic reaction to peanuts or something like that. Basically, what your body is thinking is that allergy is an antigen. It's a toxin that your body thinks is going to harm you, even though it won't. So it's tricking our body into thinking this allergen is a pathogen, which it isn't, but that's what happens in an allergy response. I'm not going to go into all these different types of syndromes. AIDS is definitely another one. It's a unique one. The loss of the helper T cell. Remember, the helper T cell activated both parts of the acquired immunity. So HIV is a loss of helper T cells. So you don't really have an acquired immunity anymore. But that is the immune system. We'll review that next week in class.